Hey 8th graders, I just wanted to give you guys a really quick video. The last couple days we've kind of been starting something new. After finishing up phase change, we're kind of shifting into the part of phase change that answers the question of why is one substance a different state of matter at the same temperature. So on Monday, I believe it was, you guys did the evaporation, or I guess it was Tuesday. Tuesday. You did the evaporation experiment where you guys had different substances and you saw that they evaporated or turned into a gas. Some did faster than others. So like the rubbing alcohol evaporated pretty fast versus like the water didn't evaporate as fast. So I asked you guys kind of which ones evaporated the fastest, and then I asked you guys to give me an explanation as to why. And so I'm sure a lot of you guys said something along the lines of it has different boiling points or different temperatures at which it evaporates. But the question I'm going to help you guys answer today is why. Okay, so why do those things evaporate faster than others, or why are certain substances like oxygen a gas at room temperature versus something like silver as a solid or mercury as a liquid? Okay, and the answer to all of this that you guys maybe are kind of catching on to with the article that you read on Wednesday, the liquid oxygen, is that different molecules have different attraction to each other. So those substances that have good attraction between their molecules, they have a harder time phase changing. So they have a harder time going from a solid to a liquid and a liquid to a gas. Okay, those that don't have attraction to each other have no problem at all. And generally we're going to see those being like gas at room temperature, things like that. So they all just kind of depend on whether they have like a high, medium, or low attraction between molecules. So the demonstration I kind of want to give you guys today to help you guys explain this, and we really didn't get a chance to do this in class, but I know we've kind of alluded to it, is this little marble. So in this cup I have just some BBs. Okay, and we're going to pretend that these BBs have no attraction to each other, which really they don't. Okay, so if I just have the cup sitting, this would be kind of a solid at room temperature. The molecules are kind of moving in place, but not very much, not very high energy. I'm not putting any energy into them. As I start to wiggle them more, I'm adding more energy, so that would kind of show us a phase change from a solid to a liquid. And then if I really add a lot of energy, okay, I've changed those molecules from a solid to a liquid and then a liquid to a gas. So by adding more energy or having maybe more temperature would be the better term in real life. You guys have taken in, you had no problem changing these to a gas, okay? On the other hand though, if we look at something that has a little bit more attraction than those BBs, is I have these magnetic marbles. So these are just little magnets. So same thing, as they're sitting, they're probably a solid. That would still be really low energy. That would probably be a pretty cold temperature, like if we were looking at liquid nitrogen or something, or dry ice, which is, like you guys know, solid carbon dioxide. So same kind of thing. If I start shaking those, this is about the same amount that I shook the BBs to turn them into a liquid. If I start shaking those a little bit, you guys can see they're kind of acting a little bit more like a liquid, but not really. I mean, they're really just kind of vibrating in place. They're not moving past each other. So it takes a lot more energy for me to turn them into a liquid, and even a lot more energy to turn them into a gas. But even then, they're not really moving away from each other. Okay, so if you didn't hear that, it takes a lot more energy to get them to move away from each other, like gases do. So again, things that have more attraction to each other, it takes a lot more energy and a lot more temperature for them to change from a solid liquid to a gas and to have those molecules freedom of movement move. So when you guys are going through this next couple of days, I know yesterday you guys looked at a simulation where you changed the molecular attraction and were able to see kind of how that changes the state of matter. As you guys are going through these, keep in mind this kind of marble demonstration of things like the BBs that have no attraction to each other. I don't have to put very much energy in to get them to change their state of matter, okay? Versus these magnetic marbles, okay? Because they're attracted to each other, it takes a lot more energy, and I still really don't get them to move away from each other like you would see in a gas. They all kind of move as a unit, okay? So if you guys have any questions on that or you're confused on that, please let me know. I'm going to be doing, and I don't know if this video will catch you too late, but I am going to be doing chats for you guys every Wednesday morning. 5th period, you guys will go at probably about, let's see here, 9:45, and 6th period you'll go about 10. So if you guys have any questions or you guys just want to check in and say hi, we'll do that every Wednesday morning at, again, 9:45 and 10 o'clock. I hope you guys are doing well. You're not getting bored. I'm going to start posting some fun little things that you guys can participate on at home if you're just sick of watching Netflix and doing homework. So anyway, stay tuned. Take care, and I will talk to you guys later. Bye.